Hi everyone, and welcome back to another episode of Dr. Kyle Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going through metallic bonding. So if you like the sound of that, give the video a thumbs up, subscribe to the channel, turn on all bell notifications, and get a pen and paper, and let's go ahead and jump in. Okay, so some key information first of all. So metallic bonding is between metal atoms only. So we've already seen in previous videos, and I would recommend you go back over those if you haven't watched them already, things like sodium and chlorine, metal and a non-metal, is ionic. If it is two non-metals together, so for example carbon and oxygen, it's covalent. And so now, if we had something like titanium, remember it's not just one singular atom of titanium, you have a lump of titanium metal. And so when all of the titanium atoms are just by themselves, it's metallic bonding. So metal structures consist of positive metal ions. They are surrounded by delocalized electrons. They're arranged in layers in a giant lattice structure. Now this is really key information about the structure of a metal. Now, metals have high melting points due to the fact they have strong metallic bonds. And so when you have a metallic bond, it's a very strong bond, therefore high melting point. Okay, so what's going on then in the bonding of metallic bonds? So here on this side, we have got our metal atoms. And at the moment, you can see each of these has their electron going around the positive nucleus as always. Essentially, what happens is as the atoms get closer and closer together, eventually the delocalized electrons spread out, and I've represented that in this blue circle here. So this is delocalized electrons. And so essentially all the positive charges, or all the metal ions, give off their delocalized electrons, and we end up with a huge array of delocalized electrons moving all over and around the positive metal ions. And so you end up with an electrostatic force of attraction between the positive metal ion and all of these delocalized electrons, making a very strong bond. Essentially, the delocalized electrons are acting as a sort of like glue, which I say in inverted commas, please do not write that in your exam, to hold on to the positive metal ions. And so we can often say that the structure of a metal is looking like this, and you should be able to recognize this in an exam. You should also be able to recognize this one as an example as a potential structure of a metal too. Okay, so what we're going to look at now is we're going to describe the structure of gold. So what I want you to understand here is gold is obviously a metal. It's a transition metal, which we've done in a previous video. But this question could also be describe the structure of silver, or it could be describe the structure of copper. And the answer is exactly the same for any metal on the periodic table. So as soon as it says in a question, describe the structure of whatever metal, you use the same structure for every single question. So what I would do is I would simply just draw myself a little diagram of a metal on the side to remind me. So I'm going to draw my positive ions, just a nice quick diagram, doesn't have to be super neat, on the side of my exam paper or my homework. And then I've got lots of these electrons floating around, these delocalized electrons holding on to all of these positive metal ions. So now I'm going to describe the structure. So gold, or remember any metal, is arranged with the positive ions in layers, surrounded by delocalized electrons in a giant lattice structure, or a giant metallic structure, you could also say. Just write metallic underneath there as well. Now all lattice means repeating unit over again. So you've got positive, 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 positive. So lattice is just repeating unit. So we're getting our marks here from arranged with the positive ions in layers. So tick, tick. Surrounded by those delocalized electrons, tick, in a giant lattice structure, tick. And remember, it can literally be any metal. So all you have to do is be able to describe the structure of a metal, and you can answer this for any single question or any type of metal. Let's have another look at another question. So why can sodium conduct electricity? So remember, sodium is a metal. This could also be copper, or it could be lithium. It could be any of the metals. They can all conduct electricity. So again, our structure, positive, positive, positive. Let's think about it. So we've got those layers of positive ions surrounded by our delocalized electrons. E minus, E minus, E minus, and my delocalized electrons. And so let's think, why can it conduct electricity? So sodium has delocalized electrons, which can carry the charge throughout the structure. Job done. There's our 3 marks in the bag. Tick, tick, and tick. And so we could also think about this question in terms of heat. So not only can the delocalized electrons carry the charge, so they would just pick up the charge there, bump into that one, bump into the next one, be another one here obviously, and then bump into the next one. It could also pick up the heat, and so those electrons can help transfer heat through the structure as well. And remember, just as a quick physics recap, what they could also do is as you're giving the particles more energy, they start to vibrate more. Those vibrations pass on to the next particle, which pass on to the next particle, conducting that heat through. So metals are really good conductors because of their delocalized electrons and the fact that their particles are so close together so that they can conduct the heat. Okay, so what we've done today then is we've described metallic bonding and explained the properties of these giant structures, including why they conduct thermal energy and electricity and have high melting and boiling points. Thank you very much for watching. Please do go through my other videos on my playlist for more GCSE science content. Please do subscribe to the channel and give the video a thumbs up if you haven't already. Finally, if you ever need help with your GCSE science, don't forget Dr. Gile Explains. Thanks very much. Bye-bye.